Now in exercise 3C, we actually get onto the calculus of the log function. And by the calculus, I mean the operation of differentiation. And of course, then it'll be followed in a couple of exercises' time by the integration. So let's start by looking at differentiating the log function. It's a nice, simple connection. When you differentiate the log of x, and it is only to base e, then you simply get the derivative, or dy dx, is 1 on x. So some interesting things, an interesting thing is, we have a function which has this log aspect to it. However, its derivative doesn't reflect anything about logs. It's simply 1 on x. It's a fraction. Now, we probably haven't seen such a drastic change between a function and its derivative ever before. And in fact, with the exponential, we had quite the opposite. We had that the derivative of an exponential is the exponential, and the derivative of any aspect of that exponential that has a function in x in it. And previously, with our polynomials, x to the power, then it was bring the power to the front and subtract 1 from the power. There was great similarity. We still had x's. It was only when it was x to the power 1 and it went to a constant that it looked significantly different. However, now our function has log in it, and its derivative has no sign of the log. Now, I know I'm jumping right ahead, but we know that that integration is the reverse of differentiating, so you can expect now to be integrating 1 on x, and you have to recognise that this results in the log function plus a constant if it's an indefinite integral. There is nothing about this 1 on x that suggests it's going to turn into a log, unlike the integral of e to the x. Well, that is e to the x plus a constant, because we know that about e to the x, and we can see it. We can see e to the x actually written there. Here, in this integration, we see nothing suggesting log, except that x is in the denominator and it is to the power 1. So x is in the denominator. But that's confusing also, because we've had x in the denominator before. And when we've got the integral, for example, of 1 on x squared, we don't go to a log. This doesn't go back to log. This is actually equal to the integral of x to the minus 2, and I can simply add 1 to the index and divide by the new index. Add 1 to the index, divide by the new index, plus a constant. So this is minus 1 on x plus c after integrating. Okay, but for now, I think that it's really important that when you differentiate, you actually take time to look at what you produce, because that is the thing that you'll be asked to integrate. So keep that in mind. The function of a function rule applies. So if we've got y is equal to the log of, rather than just a simple x, if it's some little function in x, then it is still this idea 1 over the function in x. So it's always 1 over whatever comes after log to base e. It's 1 over that. But since that is a little function in x, then we must differentiate that and multiply by its derivative. You might also see log to base e of this idea, and we would have, again, 1 over this ax plus b, 1 over it, but then we must go in and differentiate inside this little function, and the derivative of ax plus b would be a, and you might see that written as a over ax plus b. So that's about all there is to say about the derivative of the log. I'm going to pause the video. I'm going to stop the video. I'll just write up the solutions to the examples, and hopefully that will be enough for you to see the actual rule working. And then you'll be able to do the exercise on 3C. And actually, I could also talk about 3D because it's just the application of differentiation. Now, we looked at the application of differentiation when we learnt to differentiate our basic polynomial, bringing the power to the front, subtract 1 from the power. We looked at applications when we, when we were differentiating the exponential. And now we're looking at applications when the function has a log in it. These applications will all basically be the same. They're all talking about the gradient of the function, or turning points, or equations of tangents and equations of normals. All these applications are similar. They're all similar. It's just that the function that you're dealing with is different. And as long as you're obeying the rules about logs and the rules about the rule about differentiating it, then you shouldn't have too much trouble. And like I said with the with 3C, I'll just work through the examples, and I'll do the same here in 3D. I'll work through that example. I'll leave it here on OneNote, and you can have a look at it, and you can go on then and do 3D as well as 3C.